Hey, this is Dr. B, and this is worksheet 7.2, Ionic Compounds Worksheet. This is an introductory worksheet for ionic compounds. We'll be dealing only with individual atoms. Be sure to read this entire document before you dive in, which is what we're going to do right now. If your two atoms involved are sodium and chlorine, they can ionize to form sodium chloride. Sodium being +1, it's in the first column right there. Chlorine becomes chloride after it gains an electron, and it is -1. This shows you we have a nice +1, -1 match, and you could simply drop and switch those numbers in to come up with the relative amounts of each. In this case, just one of each. We drop the 1, it is assumed. If you have bromine and potassium, something just doesn't seem right. Bromine potassiide? I don't think so. Have a look and you'll notice that bromine is to the right of the staircase, and potassium is to the left. We always begin with the cation, so this will become potassium bromide. The charges once again are +1 and -1, so we are good to go with KBr. Magnesium, good to the left of the staircase being right down there. Iodine to the right of the staircase. Magnesium iodide is correct. But in this case, magnesium is in the second column. It will form a +2 cation. Drop and switch, put the 2 down there, put the 1 there, and you'll see that this is Mgi2. The 2 -1s nicely offset the +2 charge of magnesium. What two atoms would be combining after they ionize to form cesium oxide? Clearly, cesium and oxygen. Great. Is it CSO? Well, let's have a look. cesium. There it is. It's a group 1, so we're going to put a 1 above that. The oxide, on the other hand, we can find that here is -2. Drop and switch these, and you get CS2O1. Cesium oxide. 2 + 2's offset your -2. Well, if you're going to be making this substance, we will be calling this aluminum chloride. Agreed, not aluminum trichloride. We only do that for substances which covalently bond. It must come from aluminum and chlorine to form aluminum chloride. We do need the 3 Cl's because when you write the charges above, which you always should do, friendly note, these are just your personal little reminders here. These don't belong in the final answer. Most teachers don't mind if they see those. In fact, they like to see those. That means you're being diligent. But the 3 will go over here, and the 1 goes over here. The 3 -1s nicely offset the +3 for aluminum. How about this? Is rubidium sulfide reasonable? I think it is. There's our B, and then there's your S. Let's worry about how many of each after we name it, because it doesn't affect the name. Looks like we're going to need 2 rubidiums. Sulfur is -2. We looked them up. 2 goes there. The 1 goes there. Rb2S. Sodium phosphide, I guess, comes from sodium and phosphorus. The charges on those are +1 and -3 respectively. We will need 3 sodiums. Maybe you could very quickly figure out that that's Na3P by just seeing the charges and switching them in your mind. Sodium and calcium. Okay, what's with these NBs? Well, sodium is to the left of the staircase, as is calcium. Neither one of these is going to gain electrons. They cannot form an ionic compound. So in terms of the ionic compound that would be formed, it would not. So it did show up right here. If no bond forms, write NB. Tricky, huh? And this is in fact magnesium nitride. Start left of the staircase. Magnesium. Go right of the staircase. Nitride. Charges are 2 and 3 here. So we will just switch them. The 3 goes there and the 2 goes there. Convince yourself that's reasonable. 3 + 2's, wow, that would be +2 +4 +6 accumulated. 2 -3's is -6. The +6 offsets the -6. And this is an introduction to Ionic Compounds Worksheet 7.2.